So in this submodule, we want to look at design principles that are applicable to geothermal heat pumps. And specifically, we want to focus on applicable standards, codes, and practices and national norms for geothermal systems. Uh, so in order to cover this topic, we want to first look at some general principles of design. And I would refer you to submodules 1.2, 1.3, 1.4, 1.9, and 1.10 of this course if you want to have some more information about the specific topics. But the point really of the design principles is to demonstrate, as is shown in the chart on the right-hand side of the slide, the principles by which a designer would undertake the design of a geothermal system. So you can see that there are key parts of background information that are required for completing the design. And these do include the definition of the ground conditions, including the thermal properties or the hydraulic properties of an aquifer. But more importantly, they need to be able to specify the energy demand profile. So the heating, the space heating, the domestic hot water, and the cooling energy demand or the base load for a particular application. The heating and cooling peaks, so the maximum capacity, installed capacity of the system, and the number of hours that those need to run at are critical. So as part of the design process, you can see that once you have the energy demand and you have the subsurface information, which you might acquire through some site-specific measurements that are covered in some of the other submodules, you're then able to go and consider the regulatory requirements and the standards that are applicable in a particular jurisdiction in order to complete your final design. So in order to comply with those regulatory standards and requirements, generally a geothermal system designer needs to consider the ground temperatures in winter and summer operating conditions. They need to ensure that the hydraulic design of the system from a technical standpoint works correctly into the manufacturer's specifications and the long-term performance of the system, and in particular the ground temperatures and the performance of those with respect to the operation of the heat pump are met throughout the life cycle of the system.